So we're looking at log properties, and we have a property that says if the argument of that log is multiplied, you can expand it into two separate logs with the same base, but we add them. So look in here, log of 6. 6 is 2 times 3. So we can make that log of 2 plus log of 3. Log base 7 of 45. 45 is 5 times 9. So we can make that log base 7 of 5 plus log base 7 of 9. Now some books and some things are going to want us to go even further, because 9 can be written as 3 times 3. You would go this far. Okay? You could even go that far. Not right now, no. Okay? Here, 5 times x. So log base 2 of 5 plus log base 2 of x. Times is meaning multiply. Wait, times always means multiply. But in log, times means you can add the two logs separately. So looking up here, we have the sum of two logs with the same base. So we just multiply the arguments. So we get log base 2 of 28. Here, this becomes log of 100. Now we haven't discussed this yet, but when you don't have a base written, it's understood to be 10. And this can actually be simplified since when we're evaluating a log, we say the base to what power gives us this number. So 10 to what power gives us 100? The second power. That's how I simplified this to get a 2. I said the understood base is 10. What power do I have to raise that to get 100? And then you look here, and we have 2x and 4x squared, which multiply to give us 8x to the third. All right, that was a quick recap of that.
If that was log 3, like log base 3 to 3,
it'd be 1. Mm-hmm. And that's a property we're going to look at. So our quotient property, if for multiplication we added, what do you think we're going to do for division? We're going to subtract. So this would be log base b of m minus log base b of n. So whereas multiplication, we added 2 logs, for division, we can subtract 2 logs. So the first one. Actually, let's skip the first row and go down to the second row. No, let's do this one. All right, log base 3 of, what are we going to get? What do you do when you see subtraction? You divide. So you're going to have 24 divided by 8. So that's log base 3 of 3, which Gracie just told us is equal to what? 1, since you raised 3 to the first power to get 3. What power do I have to raise this base to get this number? All right, so see, we divided. Because of the minus sign, we divided the 24 and the 8 to get 3. Okay, number 8. Log base 2 of what? 15 divided by 15, which is 1. Guys, this can actually be simplified. Stuttered to whoever can tell me first what power I have to raise 2 to get 1. Who said it? Sarah said it first. Good job. Anything raised to the 0 power is 1. So the simplified version of this is 0. All right, what about the next one? What are we going to do? You actually do, because you're dividing x to the 9th by x squared. And when you're dividing, you subtract the exponents. So that was a tricky one right there. Because you had to change subtraction to division, but division meant subtract. So that was a tricky one. Why are these rules so interrelated? Well, logarithms are the inverses of exponents. So like the inverse of 2 to the x is log base 2 of x. Alright, so looking at the rest of the quotient property, what is something that divides to give you 4? 8 and 2. So you could say log base 8 of 8 minus log base 8 of 2. And I can simplify both of these actually. What is log base 8 of 8?
So do we have to simplify?
Actually, it doesn't say simplify it, so we'll just leave it. But you could. And then, can anybody tell me what log base 8 of 2 would be? 8 to the what power gives you 2? 1/3. That's right, because it's the cube root of 8 is 2, so that's the 1/3 power. Alright, so this one would be log base 5 of 1 minus log base 5 of 3. See if you can do this one. All right, our next property is the power property. If you have an exponent, you bring it down to the front. If there's a number in front multiplied, then we know that it is an exponent.
Wait,
You're fixing to see the example. What now? The whole second part? I feel like I did. That's unfortunate. Okay, so here we have log base 4 of 2, but this number in front is an exponent. So that's log base 4 of 2 to the 5th, which would be log base 4 of 32, which we could actually simplify if we wanted to, but I'm not going to take the time because it's a fraction. It's 5/2.
of what?
2,
31?
because 2 to the 5th power is 32. All right, here we have log base 2 of x to the 7th. The exponent just comes to the back. That number in front is the exponent, and it just comes to the back. And then finally, we have log of 8 raised to the 1/3. What is 8 to the 1/3? 2. It's the cube root of 8, which is 2. So you have log of 2. And so now we're just going to go backwards. Now we're just going backwards. So here, you see that exponent? It's coming to the front. Now this is something we can simplify. All right, we can simplify this. Log base 2 of 8 means 2 to what power gives me 8? 3. We're asking ourselves 2 to what power gives me 8, and that's 3. So you have 7 times 3, which is 21. Which I know is going way past your box on your paper. All right, what are we going to do with this next one? Where do exponents go when we're expanding? In front. But there's already a 3 in front. So what are we going to do? We're going to multiply them together and get 3x minus 3. Log 4. And you could distribute the 3x to the log 4 and the negative 3 to the log 4. So it would be written like this. 3x log 4 minus 3 log 4. What now? I heard somebody say something. Well, you have x minus 1, so that's 3x minus 3. So this is a minus. So then I just distributed 3x to log 4. Right, so I have negative 3. Yeah, I'm just distributing. Like, see this x minus 1? When I bring it to the front, I multiply it by 3. 3 times x minus 1 is 3x minus 3. So that's where I got this. And then I had my log 4. So then I said 3x times log 4 is 3x log 4. And negative 3 times log 4 is negative 3 log 4. Is that... Did I answer your question? Okay. And this last one can be a little confusing because you don't see an exponent. Who can tell me the hidden exponent? What is it? Not 1. It's a fraction. 1/2. Where are you getting 1/2? The square root is a hidden exponent. Remember I said when we see exponents, we should think radicals. I mean, not exponents, but fraction exponents, we should think radicals. When we see radicals, we think fraction exponents. The square root of w can be written as w to the 1/2. So then we bring our exponent down to the front. Final answer. I never put a box around this final answer because it
Wait, can you go over that one again?
took forever.
I was still focusing on those.
Yeah, give me a second. All right. So remember, when we're condensing into a single logarithm, plus becomes multiply, minus becomes divide, a number in front becomes an exponent. So we see this. The 2 is only in front of the log 6. So this 2 only goes here. What's that going to make that? Log of what? 6 squared, which is 36, minus log of 9. So I brought the exponent back to the 6. 6 squared is 36. What does minus tell us to do? Divide. So 36 divided by 9 is 4. You cannot simplify this. So we have log 4. What's the understood base of this? There's not a power of 10 that gives you 4. All right, looking at the second one. The 4 goes with which number? The A. The 2 goes with the B, and then plus is going to have us do what? Multiply. So we're going to have log base 4 of A to the 4th plus log base 4 of B squared. Okay, because this 2 goes back here. No, plus tells you to multiply, so you just have log base 4 of A to the 4th B squared. And guys, I would probably put parentheses around that so that somebody reading this knows that the log base 4 goes with the A to the 4th and the B squared. 1 second. Now I'm recording. Okay, so we're on this last problem. Sorry that I forgot to record parts in the middle. But we are expanding this. So we have log of 7x to the 3rd, but that radical means we're what power? The 1/2 power. That's a square root. So that's the 1/2 power that we're raising 7x to the 3rd to. Then I raise both of these to that power. So that's log of 7 to the 1/2, x to the 3/2, because when you multiply 3 times 1/2, you get 3/2. Then we're going to add these two. Why am I going to add them? Because it's multiplication, and I'm going to bring the exponents to the front. So that'll be 1/2 log 7 plus 3/2 log x. Final answer. Hallelujah. And what questions do you have?